Hello! Today I'm going to show you how to decompose partial fractions, but when we have a repeated fraction on the bottom. So I'll write out a quick example we're going to do. We'll have x plus 2 on the bottom, alongside the repeated fraction of x minus 1 squared. It's repeated because it's been squared. Could have been cubed or to the raised to the power 4, something like that. It's the same sort of method. On the numerator then, we'll have x minus 7 multiplied by x minus 2. And that thing is equal then to, well, we want to write this as a sum of simpler fractions. So where each fraction has the denominator of the factors over here. So the first one will have x plus 2 on the bottom, and we'll say we have a lots of those. For the second one, we'll have x minus 1, and we'll have b lots of them. And for the third then, we would write the third factor here, but the third factor is the same as this one. It's just x minus 1. And if we just wrote c, we may as well just combine b and c into one constant. So how we get around that is we write x minus 1 squared, all underneath c. So as always then, we'll try and turn this right hand side into one fraction again by multiplying top and bottom by the other factors that we're missing basically from each one. So a is going to be multiplied by x minus 1 squared. B will be multiplied by, well, we need the x plus 2, and we need another x minus 1. And for c, it's going to be a little bit simpler because it's already got the square, so we only need the x plus 2 as a factor. So the left hand side then, just the numerator, x minus 7 multiplied by x minus 2. Beautiful. So as always then, we're going to try and eliminate some of our constants and make it so that we just have one of them each time and then solve it very simply. So we'll pick x is equal to 1 for the first one. X is equal to 1. The left hand side, well, 1 minus 7 is minus 6. 1 minus 2 is minus 1. So therefore that's going to be positive 6 when multiplied together. The right hand side, well, the a term will go to 0, the b term will go to 0, and we're left with the c term. 1 plus 2 gives us 3, so we have 3 lots of c. We divide both sides by 3. What we're left with is c is equal to 2. Very nice. Doing the same thing then, but we'll choose now x is equal to minus 2 to make this bracket disappear. So x is equal to minus 2. Left hand side, minus 2 minus 7 is minus 9. Minus 2 gives us minus 4. So minus 9 and minus 4 times together gives us 36. Is equal then to the right hand side. Well, this term goes to 0, this term goes to 0, so we're left with just the a term. Minus 2 minus 1 is minus 3. When we square that, we get 9. So we have 9 lots of a. Dividing both sides by 9, we're left with a is equal to 4. Beautiful. What you can see now is where we'd want to plug in sort of the reverse of the other factor. We can't do that because we've already used minus 2 and plus 1. So what we do now is we're going to compare coefficients. And you can compare coefficients of any part of x, but it's generally easier to do the highest one first. So the highest one in this case is going to be x squared. So when we look at that, the left hand side, if we were to expand this out, x squared would be just a singular x squared, so it's going to be 1 on the left. On the right hand side then, we would have 1 lots of a, plus how many lots of b? 1 lot of b. And how many lots of c? Well, there's no x squared there. If we expand these brackets out, there'd be just cx, whereas compared to here we'd have b lots of x squared. So there's no c in this thing here. So what we can do is we can plug in now the value of 4 for a, and say that 1 is equal to 4 plus b. So we take 4 from both sides, what we see is that b is equal to minus 5. Beautiful. So just rewriting that out, our entire fraction then can be rewritten if we call this f, just to save having to write that whole thing again. F is equal to a over x plus 2, where a was 4. B is minus 5, so it's going to be minus 5 over x minus 1. And c is 2, so it's plus 2 over x minus 1 squared. Beautiful. Again, this method will only work if the order of the denominator is higher or equal to the order of the numerator. Sorry, just higher, not equal to. So if the order of the denominator is higher than the order of the numerator, this will work.